So let's go with the first one. So scatter plot. So my x's, which ones can I control? The amount of drug I have or the reaction time?
Amount of drugs.
Amount of drugs. So it's my x. My y is the reaction time. So here my x's need to go from 1 to 6.5. Everybody kind of follow that?
Yes.
So I'll start off with 1, 2, 3, 4, 5, 6, 7. And then my y's should always start at 0, otherwise we have this misleading graph. But it needs to go as high as what?
5.
Yeah, 5. So I'll start with 0 and go 1, 2, 3, 4, 5. Alright, and then we gotta label it. So this bottom part is, make sure you label, this is amount in drug, amount of drug percent. And then this over here is reaction time. In seconds. Okay. And then just go ahead and pop them in there. So then you should have something that's sort of like this. More or less. It's not perfect.
Yep.
Something sort of like that, yeah? Okay. Is that correlated? Does it seem like it's sort of line-like?
Yes.
Yeah. Looks like it sort of has a positive correlation. Everybody sort of follow that?
Yep.
All right. And then B and C are basically just doing a hypothesis test. So I'm just going to start with step 1. What's my step 1?
H naught
H naught, my
equals
hypothesis. H naught and H1.
Yep.
So what's my H naught for these? Always, always, always.
Equals rho
Yeah.
equals 0.
Rho equals 0. Good?
Yes.
What's my H1?
Rho is not equals
Rho
0.
is not equal to 0. Great. Perfect. Our claim is pretty much always going to be H1 with chapter 10. It's always going to be that there is a correlation. All right, let's move on to step 2. What's my step 2?
Critical value.
Yeah. Find your critical value and draw a picture. So here's my picture. And my degrees of freedom is
8.
8? Really? No.
10. Sorry.
Degrees of freedom is 10. My alpha is 0.05, I think. So you're going to pull out your little table. And what are you going to get for your critical value? 576. So you're going to have negative 0.576 here and positive 0.576. On board? And then this right here is 0. Everybody okay with that part?
Yes.
This over here is negative 1. This over here is positive 1. Everybody follow, because perfect correlation is negative 1 or positive 1. Those are the two perfect correlations, just negative or positive slopes. And then in the middle of 0 is no correlation whatsoever. Okay, great. So then my step 3 is going to be finding my R. So this is how you show your work, guys.
Start.
L1, the little arrow, that's my data, it's in L1. L2, little arrow, that's my data, I put in L2. And then, stat,
Lin.
test,
Lin. Reg. T test.
yep, lin, reg, t-test of what?
L1, L2.
Yep, L1, comma, L2. Okay? And from that you got R equals what?
0.9.
982?
9.9.
9 what?
409.
941?
Yes.
941, yeah.
Okay, great.
Basically.
Where does it go? It goes in over here somewhere, 0.941. Is it positive or negative?
Positive.
Okay, good. All right, positive 9.941. So are we going to reject H naught or not reject H naught?
Reject.
Reject H naught. which means,
There is enough evidence.
is it a line or not a line?
There's a line.
It's a line. It's a line. It's a line. Okay?
Yes.
So then on step 5, we have enough evidence
To support the claim that there is a correlation.
to support claim.
There is a linear correlation.
Yeah, I just say claim of a linear correlation. You can just put of a correlation.
Uh-huh.
That's fine. That's good enough. Correlation
Between
between
amount of drug and reaction time.
amount of drug and reaction time. Perfect. Ideally, you put linear correlation, but I'm okay with. We're not doing any other correlations here, so that's fine. All right. So do you guys need just a couple minutes to finish up part 2? All right. I'll give you guys a few more minutes for that part. Now you kind of know how it should look.